Hello, today in Redox Chemistry, this is going to feel like we are taking a step back in time, reviewing some ideas that we've covered a long time ago back in our periodic table chapter where we talked about metals and nonmetals. So as we can see, I have kind of color-coded my periodic table. You'll notice that there is a yellow dividing line that separates the metals from the nonmetals. The metals I've outlined for you in blue. The nonmetals are indicated in kind of a pinkish color. Notice up here that we have hydrogen in the upper left-hand corner. That's also the pink color. It is not a metal. So again, keep those ideas in mind. As we look at different various elements, we have to understand exactly, first off, is the substance a metal? Is it a non-metal? That issue is just, can you tell the left side from the right side and make sure that you have the correct element? The next thing is the difference between a metal and its ion is the element would have no charge and the ion would have the charge on the periodic table. Thus is true also for a nonmetal. A nonmetal does not have a charge, but when it turns into an ion, it does have a charge. So now, if you're taking a look at what we're doing today, you'll notice that the element is going to be listed on the left-hand side of both equations. That's the element right there, and that's the element right there. Notice that the ion is written on the right-hand side of the arrow. The only difference between these reactions that we're looking at is where the electrons are planted. In a metal, metals generally tend to lose electrons. That's what we say when a metal is rusting. It undergoes oxidation. So that's really what oxidation is all about. So the term oxidation is listed right there. Reduction applies generally to a nonmetal. You'll notice that in a reduction, you're having a gaining of electrons. The electrons gain is found, I got to spell that right, gaining electrons. And in this one, we're losing electrons. All right. So if they give me an element, and they say, for instance, my element today that we're going to be looking at is going to be calcium, for instance, I have to look on my periodic table and say, where is calcium? There's calcium right there. So I got to ask myself, is it a metal? Is it a non-metal? Not a hard question because we have it listed right here that it is a metal. I'm going to start with my calcium. That's calcium to 0. And by looking at my periodic table, I should be able to see what the charge is. Let me see if I can expand that up for you. And the charge is listed right there. So not a hard idea to figure out the charge. You just have to make sure you have your periodic table handy. That's going to be the charge that Ca will become when it becomes an ion. So notice I'm fitting in the pattern. Here's the metal. All right, there's the ion. Okay, I'm just going to erase that so we don't have any. And then all I have to do is ask myself, to go from 0 to +2, how many electrons would that be? Well, if you think about it, to go from 0 to +2, that is 2 electrons. Now notice mathematically this should also make sense. Mathematically, we're looking at a sentence that's pretty much saying, if I just pull out the numbers here, 0 equals +2 plus a -2. Does that make sense? That 0 equals 2 minus 2? Well, we don't need to be in high school to figure that one out. We can figure that one out all the way back to grade school. Yes, 2 minus 2 is 0, so we're good. Now, to go on to the other side, we are now going to take a look at a nonmetal. With a nonmetal, we have to just be on guard. There are 7 diatomics listed, and I'm going to pick a diatomic. I'm going to pick hydrogen. We have to know that hydrogen, when we write it, is going to be H2. That's how we write hydrogen in its normal elemental state. it's going to take a certain amount of electrons, which we're going to figure out in a moment, to become a hydrogen ion. So you might ask yourself, oh my God, there are two charges in this box up here, +1, -1. Which one do I use? Use the top one. All right. I'm sorry. If it's going to be gaining electrons, we should go negative. So all we have to do is pick the charge that's negative. So we're going to pick, for the nonmetal, we're going to pick that it's going to be -1. So we're going to write down H -1, because if you're gaining electrons, you should go more negative, right? Now, if you take a look here, there's two hydrogens here. So before I deal with electrons, I got to make sure the atoms are balanced. There's got to be two here. So this one I did as an adjustment. That was me adjusting that, okay? H2 is because this is diatomic, as you've already learned in a previous chapter. So when we write the element in its elemental state, it has to have a 2. There are 7 diatomics, as you recall, from the old saying, have no fear of ice-cold beer, which is hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now, if we take a look at this number and this number, the change is 1. But there are 2 of these hydrogens doing that, giving me a resulting 2 electrons involved. Okay, so that's how you handle a diatomic reduction. If it was just a regular old element, like say you had sulfur, which is not a diatomic, sulfur is simply this, sulfur 0. Okay, it's going to take a certain amount of electrons. It's going to become the charge on the periodic table, which if we look up above, it'd be S -2. To go from 0 to 2 is just like walking on a number line, 2 spaces. That's how many electrons would be involved. So hopefully that was helpful in helping you with the foundational principles of redox, where oxidation is losing electrons, as we've seen in these reactions. The loss of electrons, notice loss is found on the right side, and the gaining of electrons is found on the left. When you gain electrons, you'll notice the oxidation number drops. So if you take a look from here to here, we went from 0 to -1. That's a drop. And in this case, you went from 0 to -2. That's a drop. Reduction, a drop in number. Oxidation should mean an increase in number. Let's take a look and see. Did the number increase? We started at 0. We went to +2. In that case, it was an increase. So hopefully that was helpful in helping you get some foundational ideas and some old review of concepts about the periodic table for tonight's homework.